Let's do some more examples with domain here. Let's say same directions, find the domain. And we'll do a few parts more. So let's say part A, let's say f of x is equal to 1 over x. So now, getting away from square roots for at least a moment, now we're looking at a rational function. We're looking at something with a fraction. And the most important thing is that when it comes to fractions, we cannot plug in a 0 into the denominator of a fraction. So in this case, our denominator is x. We know that denominator cannot be 0. X is already solved for here. We don't need to do any additional work. So set notation. That's a horrible curly brace there. Let's say x such that x cannot be 0. Or interval notation, maybe the number line will be helpful again. So x cannot be 0, so that's an open circle. It can be everything to the left, it can be everything to the right, it just can't be 0 itself. So we're going to have two intervals here, negative infinity to 0, union 0 to infinity. And I'm not using brackets here because that 0 is not included in my answer. Let's do another one like that. And let's do f of x is equal to 1 over x minus 3. And we have another fraction, which means we have another denominator. That denominator, in this case x minus 3, cannot equal 0. To solve for x, we're going to add 3 to both sides. Use a number line if you'd like, you don't have to. Not equal to 3, so it can be everything but 3. So x such that x is not equal to 3. Or the interval notation, negative infinity to 3, union 3 to infinity. And you'll notice on my last two answers here, they were open circles on my number line, so I'm using parentheses now, not brackets like I was for square roots. And let's ramp this up a little bit in terms of difficulty. Let's say part C, f of x is equal to 1 over x squared plus x minus 6. And okay, so we have a fraction, we have a denominator. That denominator, x squared plus x minus 6, cannot equal 0. In this case, in order to solve for x, I'm going to have to do some factoring here. And so in this case, I need factors of negative 6 that add up to positive 1. Well, factors of negative 6 that add up to positive 1, I think those are going to be positive 3 and negative 2. So positive 3 minus 2 is positive 1. We've got our 1 in front of that x there. Positive 3 times negative 2, that's equal to negative 6. So that seems to check out there. So now we have x plus 3 cannot equal 0. We have x minus 2 cannot equal 0. So x cannot equal negative 3, and x cannot equal positive 2. And I'll go ahead and do a number line. I think it's useful. Negative 3, open circle, 2, open circle. So it can be everything to the left, it can be everything in between, and it can be everything to the right. So set notation, x such that x cannot be negative 3 and 2. Interval notation, negative infinity to negative 3, that takes care of everything to the left of 3, negative 3, sorry. Also union, negative 3 to 2, that takes care of everything in between. And then union 2 to infinity there. It's everything to the right of 2.